Is the screen is visible to you? Just reply once, then I can start. Is the screen is visible?
Yes, sir.
Yes. So network address translation. This is the concept actually where see in most of the situation in organization or office, you are having private addresses over there, and for that organization, one private IP will provided for it. Sorry, one public IP is provided. Whenever there is a communication of that organization with the rest of the world, that is over the internet, that will happen to the public address. And inside the network on LAN, there are private IP addresses are there, right? So you need to map these private addresses to the public addresses for secure and effective communication. And at the same time, that will going to avoid, or that will going to suppress the limitations of IPv4 range of IP addresses. How that will see in private network, say IP address is an IP network that is not directly connected to the internet, right? Private IP network is an IP network that is not directly connected to the internet. That is for your local or office or the LAN you are using those IP address. No IP address in a private network can be assigned arbitrarily, so not registered and not guaranteed to be globally unique. Such type of private net IP addresses. So generally IP addresses are like 10.0.0 to 10.255.255.255 or 170.16.0.0 or 172.31.255.255 or 192.168.0.0 to 192.168.255.255. These are private IP addresses, like in our AITS 192.168.100. Suppose for 44, like this. These are private network, private IP addresses. Now see here the scenario. First of all, you understand the concept actually. This is private network one. This is private network. Say another private network, right? So here host H1 and H2 on LAN and with IP addresses like 10.0.1.2, 10.0.1.3, 10, and this router is there with the default gateway 10.0.1.1 on LAN interface. That is the default gateway on the LAN interface, right? Then another private IP, private network with H3, H4, you are having some another range of IP, maybe some maybe difference, for example, right? Now yes, you might see that this is 10.0.1, 10.0.1.3, same thing you will find here, but the communication will somehow different when they communicate over the internet. For this, we can say organization, these are okay for their internet communication. This is also okay for their internet communication, but if this 10.0.1.1 want to communicate on this, then that will happen through internet, and then here mapping actually perform, unique mapping will be done for this particular communication. Sometimes here you can use another private IP address like 192.168.100.4 or say whatever that range also you can use for your better understanding, right? But if you find us, you will say both the address are same, no problem, because these are two different private networks, right? So at the time of communication over the internet, they will get mapped to the public IP address. Now here on the internet, here 128.195.4.119, 128 say 143.71.21, these are the public IP addresses at this particular WAN for their communication, right? Now for a network address translation, actually a short-term solution to the problem of the depletion of IP address, right? And the long-term solution is you can use the IPv6 where maximum range of IP addresses are available. But NAT is the way to is another solution for it, right? Uh, for it, then network address translation is a way to conserve IP addresses. That is the same public IP address can use in a different fashion to a particular private IP address. That is also possible. That we'll see in due course of this particular explanation. Then NAT is a router function where IP addresses, sometimes possibly raw port numbers of IP datagrams are replaced at the boundary of a private network. So this NAT is at the router function, it's treated as a router function. So it is implemented at the router, and it will perform the mapping of private IP address to the public and reverse also, right? That means when you are sending packet from private network to public networks, it will map your private IP address to the public IP address, and at the reverse, it is mapping your public, whenever a server or that particular another destination sends the response back to you, then your public IP address should be get mapped to the according private IP address. Now NAT is the method that enables host on private networks to communicate with host on the internet. The network address translation is run on routers that connects private networks to the public internet to replace the IP address port pair of an IP packet with another IP address port pair. Now how that we'll see. Now here see in the basic operation of network address translation. Basically you should understand actually how many types of, first of all let me tell you how many types of those NAT are there, right? So if you want to know the types of NAT, I think there is one. I think this is there. There are actually three types of this network address translation like this. I hope this is visible to you. See, first same concept types. So I want to tell you the types of those IP addresses. Now here static network address translation, dynamic network address translation, and overloading NAT, that is with port address translation, NAPT. So these three you can study and work in your 1C assignment: static NAT, dynamic NAT, and say PAT with overloading. When we are concerning the static NAT, so we are with static network address translation, the network address translation router simply configures a one-to-one mapping between the private address and the register address that is used on its behalf. That is, one private address will get mapped to the one public address, and that are bind together at the router in the static network. That means that particular private address always get mapped with the same public address specified in the at the router, right? So that is static net. Now how to configure static net and all those things that we'll see. Okay, now here first of all say one-to-one address translation, that is static mapping we're going to see here. See host, this is the private network, right? So H1 is the host and this H1 wants to communicate with the H5. Now this is the private network and this is internet, that means the rest of the world, that is internet, where this private network want to send some packet. Now this H1 is assigned a private address of 10.0.1.2, right? And the public address is somehow you can say that decided for this particular private address is nothing but that is 128.143.71.21. That means it is decided that whenever this machine will interact with H5, the private address will get mapped to this particular public address. But how? Let's see. Now this packet is H1 is sending this packet with source and destination. Source is 10.0.1.2. That means this machine, and destination means 213.168.112.3. That means H5. The H5's destination is, and the H5 is having public because this is on the internet and on the one side, so it is having the public IP like 213.168.112.3. So that is the destination for this packet. Now when this particular packet reach to this particular interface or boundary where your router is there, right? And at this particular NAT is also part of that particular that means implemented at router side. So this is also termed as the NAT device, and this particular NAT device or router will maintain such type of mapping table like private address and the public address. For this particular private address, what is the public address? Now for this private address for this H1 is 10.0.1.2. So public address should be considered now 12.143.71.21. That is decided. So it is there. So whenever this packet with this source ID comes here with this particular source means private address comes here, it will get converted to this public or public address. And whenever this packet leaves this particular NAT device or this private network, then the packet will look like source is now 128.143.71.21. That means the public address is placed instead of this particular private address, right? Now this 10.0.1.2 is replaced by this public address. Destination remains same because he has to reach to this H5. Now whenever this packet reaches to this particular H5, then this H5 will process and send reply back to the H1. Now when H5 sends this particular packet, this particular packet before reaching to H1, it first of all it arrives to this particular boundary interface where your NAT device in the form of router is present, and this packet will again refer this particular table. Now source is what in this particular packet. Now source, that means H5 generated the packet, so source is 213.168.112.3. Source is fine. Destination is, though H5 wants to send the packet to H1, but it will not use 10.0.1.2. It is using the public IP. That means whatever the mentioned public ID here. So that is the destination, right? So when this packet arrives here, this destination address 1.143.71.21 will get will be matched with this particular private address, and this particular public address will get replaced by the private address. Now and then after this, when this packet leaves this device, then at H1 whatever the package reached there, that package contains the source address as this H5's address as it is, but the destination address is now its original private IP address, that is public address. This public address is get replaced by the private address, and then this particular packet reach to the destination. This is called as how network address translation occurs and actually works. And this is one-to-one mapping. It's a static static network address translation, SNAT. It is also called as SNAT, right? So this is the way you can explain this SNAT. Now say for example, there are many scenarios, like we'll say one or two. Like a corporate network has many hosts, but only a small number of public IP addresses are there, right? A corporate network has many hosts, that means lot of people are users are there, but a number of public IP provided to that corporate is small. What is the network address solution for this? A corporate network is managed with a private address space. So NAT device located at the boundary between the corporate network and the public internet manages a pool of public IP addresses. Now here, whenever the matter comes up, manages a pool of public IP addresses, it will move your concept of static network address translation towards the dynamic network address translation. I telling you dynamic network address, where a pool of public IP addresses are there. Though you are having 100 corporate network user or host and only 4 public IP addresses, so you are maintaining the pool of 4 public addresses, and which will accordingly get matched to that particular host as per their requirements. Got it? So you are managing a pool. That means you are using the concept of dynamic network address translation. Now, when host from the corporate network sends an IP datagram or packet to host in the public internet, the NAT device picks a public IP address from the address pool. It is picks from the address pool, always remember, and binds this address to the private address of the host. So not necessary each and every time the same host will get a same IP address, right? H1 may get sometime first of all .1 IP address, but next time suppose H1 again want to communicate to the destination, say H5, it will get .4 type of public address. So it is different. So it's not static, it's a dynamic. That's why you are maintaining the pool of that addresses, public addresses, right? Now here see the concept like say uh, source address is same, destination address is public address of this H5, right? Private network internet. Now here private address is 10.0.1.2, but here you are maintaining the pool of addresses. For example, public addresses are now like 128.143.71.0 to 128.143.71.30. That means total 30 public addresses are there, right? Now whenever suppose here now only H1 is there, so whenever H1 this particular packet comes here, so it will get the IP address, public IP address from this particular pool of IP addresses. So maybe 128.140.71.4 or maybe 128.140.71.29 also, whatever at that time is available, it will get that. So suppose it get 128.140.71.20. So that mapping now maintained here. The address or this packet reach here, whenever it's come back, it will again convert it to this particular H1 private address and delivers the packet. Suppose here 5, or you can say that 35 or 50 machines are there. So whenever the machines comes here, then it will going to give that particular next IP address from the pool to that particular machine as per the requirement. Fine. Then say for example, again supporting migration between network service providers. Suppose you are changing the network service providers. So how to change it? For example, now this is the host wants to send a packet with this particular suppose IP address 128.143.71.21. This is what public IP address initially provided. Now I don't want to use this public IP. That means I am changing the internet service provider, right? So if I want to change the service provider of IP with the public IP 128.190.4.0, so I'm using that 128.195.4.0. So I will just stop the communication and I will delete the entries of 128.143 from the table, and I will insert this new entries in the table like this. So this is what you can change the internet service providers at the NAT device. अगर आपने कोई ISP internet service provider its service is not good, so you are just making such type of changes. A concept of IQ masquerading. This is also called as a network address and port translation. And network address and port translation with overload. Also, port address translation that is also called as a third type of and in that network address translation, port address translation. So a single public address is mapped to multiple hosts to in a private network. Single public address is mapped to a multiple host in a private network. Remember, in dynamic, a private network may get different public IP address, but here you are having single public address. Suppose single public address, but and there are multiple hosts. So this multiple hosts are served with a single public address using the port number. So this is how a single public address, that means you are conserving the IP addresses, right? So a single public IP address can serve to multiple hosts on a private network, right? So the solution is assign private addresses to the host of the corporate network, and this NAT device modifies the port number of outgoing traffic. Now see how this will going to happen. So here say H1, H2 two hosts are there with private addresses 10.0.1.2 and the second private address is 10.0.1.3. Right now, their related public. Now here only one public address is specified 128.143.71.21. That is there. But now these two hosts want to communicate through the single public address. Now how to do this? Now for this, here whenever you are sending the source packet, so you are mentioning the private address along with the source port. So you are mentioning the port number say 2001. So here you are mentioning just confirm कहाँ तक आपको समझ में आ रहा था, दिखाई दे रहा था वहाँ पे. I have explained something actually. Up to what point मैंने आपको बताया था, यहाँ पे थोड़ा सा प्रॉब्लम होता है टीम्स का। ओके, आपको ये यहाँ तक समझ में आया था? कहाँ तक मैंने बताया? ये आईपी मैस्कुरेडिंग में बताया था मैंने, यहाँ तक दिखाई दे रहा था ना? यू कैन कंफर्म, इस स्लाइड तक आपको समझ में आ रहा था? आई थिंक सो। यहाँ से थोड़ा कनेक्शन डिस्कनेक्ट हो गया था, इजंट इट?
Yes, sir.
यहाँ से हुआ था, राइट ना? हाँ ठीक है। तो यहाँ पे मैं व्हाट आई वांट टू कन्वे, द सिंगल आईपी एड्रेस कैन बी यूज्ड for both the machines with different source addresses, and that reach to the internet, and then again reverse back, the table will get mapped. That means see, public address अगर ये IP address वापस जाता है तो it will get mapped to this particular private IP address, and same for the another host. So this is what IP masquerading, that means port address translation with overloading. So such type of examples you can also say. There are many examples you can say. For example, one more example here, say company LAN is there, right? These are 7 terminals connected. Then server is there, suppose PCs. First machine want to having IP address 10.0.1, it will get mapped to this public address and then communicate on the ISP like this. Such type of scenarios you can see, lot of scenarios you can see here. Now NAT provides transparent and bidirectional connectivity between networks on arbitrary addressing scheme. NAT eliminates costs associated with host renumbering. NAT conserves IP addresses. NAT eases IP address management and enhances network privacy. That is important one, because the third party will not directly going to view your private address. Right? Some different public address is visible to them like this. So this is what the network address translation is there. Now we'll see actually how to do this particular static or network address translation, right? Step by step. Okay. Now see here, I will just explain the steps, quite easy. Create a network as per our 1A assignment using RIP communication, routing information protocols, and 1A assignment. Same scenario I am taking here. Two switches, two machines, two switches, and two routers. Now here 192.168.1.0, 192.168.2.0 network is there, and this is 10.0.0.0. So this is public, right? 10.0, which is, or it is WAN interface. So that's why these are the public addresses. So 10.0.10.10.0.2 and 10.10. This 0 to public addresses. You can use another range of public addresses for communications, up to you, right? Now here its IP address of this machine is 1.2 and the 192.162.2 for this machine. Another configuration remains same, RIP के जो किया था हमने. Now I will just open packet tracer and we'll see it. I think लास्ट एक बैच के लिए मैंने क्या करके भी देखा था उनको, तो विल यूज दैट डायरेक्ट redim that network design. Okay, right. So static net, let all become green, so you will find that these are all working actually. It will become green in a short moment. Just wait. So this network you are supposed to consider for this static net. This is public IP address, private network with this private IP address 1.0, and here I can mention actually this is not 192.168.2.0 private, and this is actually 2.0 and 1.0, and this is 1.1 interface, and this is 2.1 LAN interface, and these are the WAN interface with IP addresses. Now all green, so network is connected. Now before we start, suppose if you want to see the router configuration, just see what is the configuration on fast ethernet 0/0. Now don't ask what is fast ethernet 0. Fast ethernet 0/0, that means LAN interface. What is the configuration for it? Just check here. So 192.168.1.1 IP address and the subnet marks, and I'm making this port on. Then serial to 0 for the same router here. That means this. See, this is on serial, right? And towards clock is there, right? If you see clock is there, then this 10.10.0.2 IP address with subnet marks, and I'm making this port on, right? And RIP configuration I am also making, because this router must know the number this network and this. So this network is 10.0.0 I'm adding, and this is 1.168.1.0 I'm adding, and I'm saving that particular configuration, right? So like this same I'm doing for this particular another router. Already it is there, just I'm showing you for your information. Fast Ethernet just 2.1, and serial port on serial to public 0 WAN interface. This is the IP address and on, and this is the RIP to network at 2.0, and this 10.0.0.0 network I'm adding here. I'm saving the setting, save like this. Okay. Now what I can do as per steps here, I have made the steps for you. Now here you can say 192.168.1.0 and 192.162 are private networks, as I told, and 10.10.0.0 is a public network on having WAN with IPs like 10.10.0.2, 10.10.0.3, or if you want to use another IP, that is 10.10.0.4, you can also use that. It's up to you. I'm just for your understanding using this 10.10.0 as it is. Now initially you can ping this 192.168.1.1.2 from this another machine. That means I'm trying to ping this particular machine PC1, PC0, that means this machine, from this particular PC. Now see what will happen. Go to desktop, command, and just I'm pinging ping 192.168. What is that? 1.2. Yes. Yes, reply. It is giving the reply. That who is giving the reply? Here actually I have configured that net. That's why it's directly not directly showing the response is coming from this but 10.10.0.2, right? So I need to clear it actually. So if I that means if I'm just remember that now the response is coming from here, that is already it is configured, so for the static net. But if I'm initially pinging this, the reply will coming from 192.168.1.2, right? For example, now if now I want to configure this particular static net, what I am supposed to do here? So here open this instruction. See here when I'm pinging this, what is coming? When I'm pinging this 192.168.1.2 initially, the response is coming from 192.168.1.2. That's from the same PC, right? But now next, now we will use this static net configuration as for that means we have to click on router 0, and we have to enter the commands like these commands we have to enter, right? So what is those commands we'll see. So here uh, router 0 we have to click, go to here, say conf t, and then we have to enter say this command. What is this? First of all, understand why we have to enter this command. IP network address translate inside source. Inside means towards PC, inside source towards LAN. What is static 192.168.1.2? That is the IP address of that PC, and what will be the public address 10.10.0.2 that I am supposed to bind with this particular static IP, right? So IP net inside source static. I'm supposed to write IP IP NAT inside source. What is source? And that is static 192.168. Say 192.168 dot 1.2. And what is public 10 dot suppose 0.2 I am using, or 0.4 you can use, it's up to you, and just press enter. Fine. Then next command, that means this 192 is the inside LAN and 10 dot is on WAN. So we map this private IP to public IP using static routing. Now next command is you have to configure serial and the fast ethernet WAN interface and the LAN interface. So for will, and this serial is outside. So int serial to oblique 0, that is uh, interface serial to oblique 0. So which is that interface when I'm writing this? That means whenever I am writing this command, um, interface serial to oblique 0, that it's coming in the interface mode. So I am talking about this, and I am binding this particular machine's static IP, private IP to the public IP. So this is inside. For this machine, this interface is outside. So I'm going to write down IP NAT outside, right? For this. Then next interface is LAN interface. For that means for this interface fast E T fast Ethernet 0/0. This is 0/0 Ethernet, right? Then you IP NAT. What is that? Inside. This is inside. That's it, right? So you also configure this particular inside interface. That is for the inside. Then next. Now we can check whether static networking work or not. Now we can check on 192.168.2.2 and trying to configure this. That means here, go here and machine. Now from this machine, click here 192.168 command prompt and say ping this machine. Which one? This 192.168.1.2. So reply is coming from 10.10.0.2. So it is expected that this 192.168 should reply, but it is not replying. This machine, that means this particular machine, this machine, ऐसा पता चला है उसको, this machine is getting the response from 10.10.0.2, but actually this is responding. But for this, it is viewed that the 10.10.0.0.2 is responding. So this is how the static routing is working, right? Then here you can add one more machine and you can also check it out. That means suppose machine में यहाँ पे add कर देता हूँ, right? से generic machine को add करके देखो आप, तो इसका IP address रहेगा. मैं अभी just say 192.168 dot what is that 1.3 suppose उसका, and this I'm setting the IP address suppose 192.168.1.3 and 198.1.1. That is the default gateway. ठीक है. Now you can try to ping this 192.168. रेड है ना, उसको ग्रीन होने दो. Now it's green. So इसका ये इथरनेट था हमारा 0/1, ये 2/1 इथरनेट पे है आपका. So you need to configure it accordingly. That means say ping 192.168.1.3. This request timeout. Now see, right now the same machine is responding 192.168.1.3, but when you use static routing here, static network address translation for this machine, then again you will get response from here, right? So this is F001 F11, and so here you can click on that routing and the same. Suppose IP using, I'm using this one dot instead of 1.2 I'm using 1.3, and suppose 10.4. that IP address I am using and entering. And suppose this is then IPNet serial interface I'm using this, and that is out, right? Done. Then inside के लिए करते हैं sysfart fa0/0. To be very specific आप fa2/1 पे भी कर सकते हो. It's up to you. Suppose मैं 0/0 पे कर देता हूँ, right? So let's see. I think it should be inside, ना? Let's check. थोड़ा टाइम लगता है अपडेट करने में टेबल. And if you repeat 192.68.1.3, see, response is coming from 10.10.0.4. Got it? So in this sort of fashion, you can do this particular static network address translation. Fine. Now then dynamic network address translation we'll see. Dynamic network address translation. What is that? This is static. Then dynamic. So just see here in the dynamic what you are supposed to do. Now I will explain you the step. Create a network as per one assignment. The same assignment. अभी हमारे पास network है, हमने किया हुआ. Then here you have to just use a pool of network addresses. So we'll use the pool of network addresses like 10.10.0.4 to 10.10.0.8, right? So initially when you ping this 109.16 at 1.2, and then you will see the message come from the same. Now when you are to configure this, these commands you are supposed to use first of all like this. So we'll see this, and then go to router 0, this one. Now go to, and one more thing, if you can clear the network address translation also, that means no IP no SH translation you can use. That means जहाँ पे हम IP net करते हैं, no IP net करते हैं, so no IP network address translation for that particular machine will be applicable. That means when you click here, and if you go in the say exit, and if you write the same command, this command, and here no IP, if you are writing say no, and enter, that's it. Again the same command for set 2, और 2 जो था ना हमारा 1.2 के लिए, वो हम नेटवर्क एड्रेस ट्रांसलेशन रिमूव कर देते हैं. ठीक है, so we can remove those, enter, that's it. So network address translation होगा नहीं आपका. You can also check through the IP addresses. टाइम लगता है थोड़ा अपडेट होने के लिए उसमें, फिर वो आपको डिफाइन कर देगा. See, वो रिमूव हो गया आपका ट्रांसलेशन. यू विल गेट द रिस्पांस फ्रॉम 192.168.1.3. क्वाइट इंटरेस्टिंग, बहुत मजा आता है करने में. अब देखो एक एक चीज धीरे धीरे करके, इट्स क्वाइट इंटरेस्टिंग. सो ठीक है, नाउ यू कैन अप्लाई द डायनेमिक नेटवर्क ट्रांसलेशन. नाउ गो टू राउटर 0. Here you can, now here in dynamic network translation, so we'll use the pool, right? So here I will use the, we will use the pool of public IP like 10.10.0.4 to 10.10.0. suppose 8 or whatever जो भी आपको लेना है. और here this is, we are now talking about dynamic net, right? So ये pool हम use करेंगे. So click here. Say config conf t, then configure t, then what you have to do, you have to follow the instructions like access list one host, and you have to consider that network. So access list one host, that means this one. So access dash list one. List one means it's a standard access list. Access list one. Uh, access list one. Host permit 192.168.1.0. That means a private network 192.168.1.0. Right? That we are using. Sorry. Access list one. Host permit 1.0. Access dash list one. Is there any access dash list one host permit 192.168.1.0? No, dash list one. Okay. List one. Host permit 192.168.1.0. What is that? Invariant would detect as systems list. Access dash host 92.168.1.0. 1.0. What's wrong in that? Access list one to we are creating no access list test one permit host one list one. Okay. Pause. Six at one dot. Suppose if we use more wildcard bit, no, what's the problem? List one. We'll close and we'll again start with the router. I think it's already there. They enable the router. Conf t configuration t. These are the commands. Access dash say list two will be access list two. What is that? Permit 92.set.1.0. What is wrong here? It's complete no access dash list two. I think access list two. Access dash list one post permit. Same. access dash list one host and you need to permit that particular host. Correct command is there. I think there is no such problem in that. I think it's already there. List host. Host list one host. Okay, suppose if I write instead of that, I think it's already get a host IP. This one. Then here this command actually tells, just listen, when you create this access list and permit on that network, IP network pool, you are having pool and pool name you have to paste in say GMW9 and the range of that particular pool and net marks we are entering for that particular pool. So here IP net pool, PNAT pool and GM.NAT and the range you are supposed to specify that is 10.10.10.10.0.8 and net marks to 0.0. I don't know why it's not working there. So you can create a fresh actually. This already we are used for the static this network design. You can create a fresh network for it and then you can apply these commands. It will going to work. No as such problem. Yesterday I have created that. I will open that. Suppose file open. I will not want to save this audio network and I will the dynamic network part of it. I hope I have saved that. Yes. Um, this dynamic network yesterday we have created, right? So these commands we are entering here. Just remember directly हमारे पास है IPNet pool. First of all, you need to create this particular access list, right? These commands are important. This first command you have to enter on the router. That means which network you are permitting. We are permitting the 192.168.1.0 private network. Then IP network pool we are creating. That means this 10.10.0.4 to 0.8 four public IP addresses we are providing in the pool named as GMW NAT and net marks we are providing. Then we are writing IP NAT inside source list one pool GMW. So inside towards the Ethernet side, we are providing this particular list with the pool address. And then as usual on serial interface, we are placing IP NAT outside and on the LAN interface, fast Ethernet, we are providing IP NAT inside. Now after this particular command, then we are trying to ping the different machines actually. That means ping 168.1.3. So you are supposed to ping those machines. It will get some time. So the pinging you are supposed to get from that particular machine. So it should get from this particular IP address. So you need to configure this again IP address here. Suppose some error is coming there. So we have to close all the packets tracer software and then we can do this. Right. So no problem. See, you can do by your own. I will share this particular file with you, and you have to just follow the instruction. You will get that particular network address, dynamic network address translation. And for, as far as the PAT, port address translation, only thing is that you need to use the overload word after that particular instruction. That means here when you go to this particular PAT, here in the pat also, what you are supposed to use. In this pat, you can use such type of network. There's three machines are there and two routers you can use, or it needs a network design you can decide. Then you have to use the command, say in interface serial and IP address for that particular communication you are supposed to set. So along you can say that IP address and all those things you can set by manually or through you can say commands. You can do this. Important command here. So when you do with this, then you can say interface inside outside for it, and these commands these are the important commands you have to use at the router. Access list one permit that a network with a wildcard mask and IP net pool name and the range of those IP address and net marks, and then same IP address net inside source list one pool and that pool name, and here overload word. This is important. This overload word you have to write after this, and the same process as dynamic net, only overload word you are supposed to use. That means a particular public IP you will overload with different port numbers. That is the meaning of this overload. So when you ping a certain machine from the another machine, so what you will get, you have to also open a debug mode. When you open a particular machine from a debug mode, so same IP address, but here inside that your port numbers occurs different each time for the communication. So that achieves your public address port address translation PAT. So in this whatever fashion pot you can also do. I will share both the files and you do it. इसमें आपके साथ अभी share करूँगा, and both files accordingly you are supposed to you have to use those files, and you can do it by your own. So I will share it first of all. Then packet tracer